In the mid-1960s, a Yale undergraduate named Fred Smith proposed an idea for a small package delivery system that routed everything through a single central hub. His professor gave him a C on the paper. Smith ignored the grade, launched FedEx, and placed that central hub in Memphis, Tennessee. Today, that single geographic choice anchors a $69 billion global logistics empire. Smith selected Memphis because it sits at the exact geographical center of the United States, experiences negligible weather-related downtime, and offered enough tax incentives to bankroll the firm's early expansion. This case study highlights a broader financial reality. For most firms, the fixed and variable costs dictated by their geography, from taxes to raw material transport, permanently lock in up to 50% of their total operating expenses. Geography is a weaponized competitive advantage, accessed through a sequence of strategic zooms and mathematical filters. The sequence begins at the macro level. When expanding internationally, a firm looks at global maps and filters those countries through 7 major success factors, weighing things like political risk, local culture, and currency exchange rates. But the most deceptive factor is labor. Management is often tempted to look at developing nations with low daily wages and assume those are the cheapest places to manufacture. This formula explains the error in that logic. It's the labor productivity calculation, and it shows that management must divide the daily labor cost by the number of units produced per day to find the true cost of human output. Look at the 2 cases on the page. The South Carolina plant pays $70 a day, but produces 60 units, yielding a labor cost of $1.17 per unit. The Latin American plant pays only $25 a day, but produces just 20 units, costing $1.25 per unit. Highly paid workers are often the more economical choice. Smart global strategy ignores the sticker price of a worker's daily wage and calculates the actual mathematical cost of their productivity. Once a country is selected, the decision zooms in to the regional level. Here, firms have to compare highly subjective factors. If you're building a theme park in Europe, how do you mathematically compare France's tax structure against Denmark's local attitude toward labor? Table 8.4 shows the factor rating method, which is the mathematical tool executives use to turn those subjective opinions into objective data. Management assigns a weighted decimal to each factor based on its importance, and then scores each country out of 100. Look at the tax structure row. France gets a 75, Denmark gets a 70. When those scores are multiplied by the weights and tallied, France edges out a clear numerical win. By forcing qualitative opinions into a rigid scoring system, the factor rating method protects billions of investment dollars from being driven by executive bias. The final zoom targets a specific site within a city. At this scale, the exact operational costs of a facility will change based on how much product the factory actually plans to build. This crossover chart illustrates locational cost volume analysis. It plots the fixed and variable costs for 3 European cities to show exactly which location provides the lowest cost at any given production volume. For low production runs, the Athens cost curve sits at the bottom, but follow the lines to exactly 1,000 units on the horizontal axis. At that specific crossover point, Brussels mathematically overtakes Athens as the most economical choice. Beyond factories, there is the precision problem, finding the exact X and Y geographic coordinates for a new warehouse so that it can supply multiple existing retail stores with minimal shipping distance. This coordinate map plots the center of gravity method. By mapping store locations onto a grid and factoring in the volume of goods shipped to each one, the formula pinpoints a perfect geographic balance point, the crosshairs right in central Ohio. By the time a company has executed this sequence, zooming from a broad global map down to exact X and Y coordinates, every ounce of wasted distance and shipping time has been mathematically eliminated. But here the logic splits. Minimizing cost, hunting cheap land, and crunching crossover charts are strategies strictly reserved for manufacturing plants and the industrial sector. If you operate a hotel, a bank, or a fast food chain in the service sector, your geographic goal is the exact opposite. You aren't trying to minimize cost. Your entire location strategy is built to maximize revenue. Because retail thrives purely on proximity to target demographics and their purchasing power, these companies employ a tactic known as clustering. Clustering explains why you constantly see fierce competitors building expensive locations right next door to each other. They absorb higher real estate costs because being in a dense, proven retail corridor guarantees the highest volume of foot traffic. An industrial factory will hide in the middle of nowhere to save a dime. A service business will pay millions to be exactly where the money flows. Today, the culmination of every strategy and mathematical formula we've explored is digitized into Geographic Information Systems, or GIS. This GIS software interface shows how modern firms overlay massive, complex datasets directly onto digital maps. By drawing concentric rings around a location, management can instantly calculate the traffic density and income levels within a specific drive time. The physical layout of the modern world is a mathematical projection. Every warehouse, fast food window, and headquarters is a calculated move on a geographic grid. The map is a high-stakes chessboard, and the companies winning the game are the ones using the math to read the board.